Hello everyone. So today we will be seeing the topic of distance vector versus the link state routing protocols. Now, if we see the fundamentals between distance vector and link stating protocols is essential for designing efficient and secure computer networks. Each protocol type employs distinct algorithms and methods to determine optimal data paths, influencing network and performance stability. So in this video we will see what what is the distance vector and link state routing protocols and how it differs from each other. So if we look at the distance vector and routing protocols, the concept is the distance vector protocols operate by each router sharing its routing table with immediate neighbors at regular intervals, propagating path cost information network wide. So in this the algorithm is common algorithm we see is included the Bellman-Ford algorithm, which calculates the shortest path by minimizing the distance metric, often the hop count of the data. So if you look into the examples, routing information protocol RIP and interior gateway routing protocol IGRP are classic examples which employ distance vector principles. So if you look at this picture, this explains the distance how the distance vector routing works. Now let us see the link state routing protocols. The link state routing protocols build a comprehensive network map by each router broadcasting state information of its directly connected link to all routers, creating a synchronized database. In this, the Dijkstra algorithm is used for the path computation, identifying the shortest routes based on the comprehensive topology data. The examples are open shortest path first and intermediate system to intermediate system are widely operated link protocols. So here in this picture we can see in the link stating protocol there is the packets are looking for the shortest distance between the another packet with to transfer the data. So if we compare both of them, distance vector is a periodic routing, gives the routing updates in periodic manner, and whereas in link state event driven updates will trigger on topology changes. In the distance vector this method is very simple to configure and implement, whereas the link state method is more complex but scalable for the large number of networks. The distance vector routing is slower convergence prone to routing loops without safeguards, whereas the link state routing is faster convergence with loop-free routes. In the distance vector, limited knowledge only neighbors distance vector, which means it is only possible with limited number of data sets and in a very short distance from each other, whereas in the link state routing is possible for global network topology awareness, which is having a large number of networks and in the various distance across. If we look at the security implications in routing protocols, the distance vector is vulnerable, has some vulnerabilities. This it is susceptible to routing attacks such as the routing table poisoning, as updates are trust based and lack robust authentication. This is the main reason of this is because of the periodic intervals given between the data transfer in the network, whereas in the link state it supports cryptographic authentication for link state advertisements, reducing risks of fake or altered routing information. So the security measures we look is our protocol specific measures which include route filtering, authentication and monitoring mechanisms to detect normalities. So looking at the convergence and considerations, distance vector convergence is slower due to the periodic updates and counting to infinity problems. Scalability is limited in the large networks. In the link state convergence, triggered updates enable rapid convergence, scales efficiently with hierarchical network design. The impact on network design is large enterprise and ISP networks typically favor link state for performance, in small to medium networks may utilize the distance vector routing. So if we look at the use cases, distance vector applications are suitable for small scale networks with straightforward topology and limited administrative overhead. The link state applications are preferred in complex large scale networks demanding fast adaptation and granular control over routing paths. If we look at the hybrid approaches, some networks employ hybrid protocols like EIGRP combining both methods to optimize performance. So this is the key takeaways. Distance vector and link state protocols differ fundamentally in data sharing and route computation approaches. Consider the network needs. Design choices should factor in network size, complexity, performance and requirement, and the security posture. Thank you.